so basically you create a scatter, you turn off the relax iterations, since you want to have a lot of points, and then you can either change the seed here, $F, and then when you scrub it, it goes, but you see it's a little bit slow because it has to regenerate those points every single time. Or you kill that and you put a point jitter here to scale the y-axis to 0.
Why you want to do that? Why you want to generate a different seed per frame?
Well, otherwise, if you are emitting, then it always emit from the same point.
Okay. In the case that you want to emit per frame.
Change.
Okay.
Yeah. Well, if you have a flat plane, you can use point jitter.
I was thinking more into a scatter to emit trees or a vegetation that I don't want, to change per frame.
Well, anyways, it's a neat trick because now you see it's really fast.
Okay.
It's real time. And you can do that with much higher amount of points. So let's try 10 million.
But if you have the point jitter, you don't need the $F on the seed, no? It's one or the other.
Exactly. I turned it off here.
Okay.
So now, but you see now this is much faster, even with 10 million points.
The point jitter is faster than doing the different seed per frame?
Yes, because all it has to do is change the position. It doesn't have to regenerate the geometry.
Okay.
So let's go back to 1 million. We don't need this. So what I would do is I would create an attribute ball, since that's the closest to thinking particles. And I don't know if you have a UV on the grid or if you apply the UV on the points. It pretty much doesn't matter because the points are going to inherit whatever the grid has. Are you still here?
Yeah, just close the door.
Okay, and now you have to change that to points because you're applying it to points. There's no vertices here.
Okay.
And now you can grab the UV, you can apply the texture. So you pick whatever image you want. Let's grab this guy.
No, take your face. It's more beautiful, Goran.
And there you go.
Beautiful.
So now we can figure out if we can extract the pretty parts of your face.
You're so stupid.
Okay. So now, whatever you want to do, you can either. I mean, it's easiest now to take a rag, actually rag, and then you do if we see that, let's say x for red, bigger than, or actually smaller than ch x or slash remove point 0. Okay.
Remove point. What does mean? The remove point 0.
So it just deletes points, and now you can see it deletes points where the red value is lower than our threshold.
Oh.
And it's a 0 to 1.
That's nice. Yeah. Can you do this with attribute bobs? There is a way, like in magmaflow, that in magmaflow I will do the selection and the kill.
Yes. So we can do it right away here. So you can either do a vector to float, like in magmaflow.
Yeah.
Or you can do get a vector component. It's the same thing. It might be a little cleaner because now you can just choose which one of the three you want. And then you do a compare. And the compare is your if statement. There is also an if statement, but the compare gives you first the bool of the if statement because you can't write conditions into an if statement. So now you say less than, and then if you middle click this input, you can say promote parameter, and that's automatically gonna
I'll put it there. Yeah.
create the parameter here. So you can call this R threshold again. And this. And now you see it renamed it here.
Yeah.
And now what you have to do is you have to put an if block. So that's basically the brackets after the if statement. So this is the if statement, and these are the brackets after the if statement, which say, well, if the if was true, then we're going to execute this code here.
Okay.
And then all you have to do is you have to get one kind of input, and then you can just say remove point, and it's the same function name. You just have to switch it down to PT. And now,
so, one second. What did you plug into the beginning if?
So
the other pit now. Okay, the number. Okay.
So what we have
PT num is a particle ID?
No, it's the point number. So you have to understand, you're not in a particle system. You are in a geometry array.
Okay.
It's basically geometry.
But then will be an index?
Yes.
In magmaflow.
It's basically, it is like an ID, but it's not an ID, because whenever you change your numbers or your geometry, it rearranges it. It's like basically pushing them all as close as possible to zero.
Yeah.
So it's an enumeration.
It's the same in magmaflow. You have index and you have ID, and the index is this, I guess.
Yes. So it's the array of points that is a geometry.
Okay.
And the moment if you delete 10, 11 is going to become 10, 12 is going to be 11, and so on.
Okay.
So now we have the same threshold here, and you see it does the same thing.
Nice. Question.
It is a bit slower because
I wanted to say that.
It's also, I think it's because it's also doing the geometry. So if we take all of this and we put it in a second attribute block, I would assume that this is going to be faster now because it doesn't have to reapply the color.
Bobs and Vex, in theory, is the same speed, or not? If you use Vex, will be faster because it doesn't need to evaluate the graph.
It should be the same because internally it is Vex. You can even display it. Let me just make sure that I do this correctly. Like this. There you go. So it's much faster again.
Yeah.
And if I do this, it's pretty much the same speed. Might be slightly slower, but I can't keep it.
Okay.
So now you have you don't have your Mataways, but you have your conditioning on top of a texture, independent of your resolution of this grid, because this grid,
Yeah. Well, I download Houdini 18.5 and they improved the scatter. Now it's called scatter and alignment, so it has more tools built in. And I was expecting that I will be able to do the scattering based on a texture. And the thing is, like, you can read from an attribute, but then you need to have the information on the point that I found. I don't found it as useful as having a texture reading directly from the texture, so it's independent from the geometry mesh resolution.
Yeah, so one thing you have to know is that it's just common to do everything at points. In Houdini, it's just a different workflow. It doesn't have any, you can't go like this is better, this is worse. In Houdini, this just is the faster workflow, and you're going to adapt methodologies to it.
Then what you do? Normally, you increase resolution of your mesh, and that's all. If you need,
it depends on what you need. I pretty much I don't remember ever emitting from a texture actually. Like it's just if you have to do it, yes, you have to look up the UV, and that's going to cost you some kind of calculation. But this is pretty much the fastest way, because the slow part of the scatter is this relaxed iteration.
Yeah.
The moment you turn that off, the number doesn't really matter.
Yeah.
And then you just get the UV directly on points. And you can't get the UV up here. It's the same deal. It's just going to transfer it. The scatter is going to look up the UVs.
Okay. Very nice, Goran. Incredible.
Yeah. Another thing is that you probably do a lot with TP is look up the closest points on a geometry.
Yes.
And in Houdini, if you work with points, you kind of get the closest point. And that is that's something that I was never happy with, because exactly your problem that you're facing now, your underlying geometry doesn't have the resolution. So what you can do, so let's apply this to this guy, and right, it's a shitty kind of a shitty geometry. So what we can do is again, it's much easier with an attribute bar. So what we can do is we can look up UV, and then you get the image or the geometry with your UV into the second input, and then all you do is like the x, y, z distance, and you plug that second input here. And now, instead of looking up the closest point, like the closest point on the geometry, we're looking up the closest kind of surface point. So whatever surface is the closest. And from there, what you get is a prim attribute. Prim attribute. And we pack that into the second one. So both of them are grabbing the same geometry. And then you can say, what do you want? I want the UV. And then I want to type that out as a new attribute. We're using UV. And now we can apply that same color again to our points. Two colors. Oh, we need the UV as well. There you go. So now it's grabbing the UV of every single surface point. So not the actual points, but the interpolation, the barycentrics between points.
Okay. Nice.
And you can get any attribute from that. So if you had, I mean, the best thing is the distance, or the most common thing you're going to use this is to get the distance directly. So it gives you the distance to the closest point it can reach on the surface, independent of how many points your grid has. So if you had let's say you only had a very simple grid, right? No points in between. And if I say less points, and then just that's my name. Doesn't make any sense because we do have a surface. Oh, yes, it makes sense. Yeah, so I'm an idiot. Of course, they're all sitting on the surface.
Mm-hmm.
So the distance is always zero.
Oh.
So we would put
I still don't know what you are doing. What's the goal?
Okay. So you see, the further away the surface goes, the more red you get. So basically, it's measuring the distance to the points. Because I was stupid. All the points are sitting on the surface, so the distance is 0. It's outputting 0. But the idea was like, if you have like such a low resolution grid, and you would always search for other points instead of the closest point on the surface, you would get a distance value, which is kind of, depending on your resolution, it doesn't make sense. So let me do the opposite, the one thing that I wanted to avoid. Maybe it's going to make more sense. So we're going to give it a little bit of a resolution here.
Mm-hmm.
And we're going to get a near point position this, and now we're going to get a point attribute, point attribute 4, and again from the same, and now we do distance to our position. Distance, maximum, this amount.
Are you rendering something? The fans are full blown up.
You can hear that?
Yes. Quite a lot.
No, but not rendering. Okay, I'm getting a bit annoyed by this. It's happening. Well, you can see that these guys are dark. So now you can see what I mean. Yeah. So if you would go by points, and depending on resolution, you wouldn't get the exact result, because if you want to see how far are your points away from the surface, well, it gives you how far away are they from the closest point.
That is not what you want.
No, and like the higher the resolution, the more precise your result.
Yeah, but still.
That's kind of not ideal. So in this case, what you do is you just get the primitive attribute, or the distance here. So, and that is, they're all sitting on the surface, so the result is 0.
And this is called XYZ dist.
Yeah, XYZ distance.
Okay.
And then it always gives you a primitive and a primitive UV, which is kind of a pericentric on that primitive.
Okay, that's nice.
It's like the same as a geom distance.
Yeah. Nice. Cool.
So, that's a little tutorial. You'll get there eventually.
Yeah. No, it starts to make sense. It's only these things that you get frustrated because it's like, fuck, why I cannot use a UV directly to scatter points? That is, in Max, normally you will have, anywhere you have a way to input a texture and drive whatever with a texture, that here it's a little more.
The cool thing is, once you have whatever you want, just select all of this, or select the input, everything but the input, and then just put it,
Houdini crash as well. Look at that. Saying that only Max crash and Max is garbage, and Houdini it's crashing quite a lot too.
I don't think I had a crash in like days.
Yeah.